Hello everyone, this is Vibhash Chaudhary, register number 497. Today we are breaking down the differences between two major processor architectures, RISC and CISC. These choices shape everything from performance to energy usage in devices you may use every day. Introduction to ISA. Instruction Set Architecture or ISA is the bridge between software and hardware. It describes which instructions a CPU can execute and how those instructions are coded, shaped, and processed. RISC stands for Reduced Instruction Set Computer, where it uses simple instruction sets, quick execution, while CISC means Complex Instruction Set Computer, which has rich instructions, more versatile but complicated hardware. RISC strives for simplicity, fewer instructions, less complexity, and faster pipelines. CISC packs more operations into each instruction, helping with programmability and code size, but making the internal control logic more elaborate. These design choices impact not just technical sides, but the way compilers and operating systems interact with hardware. RISC architecture overview. RISC instruction sets are usually fixed in size, like 32 bits, making fetching and decoding more efficient. Load store design means only dedicated instruments access memories. All other work between registers. This keeps the hardware efficient and predictable. ARM, RISC-V, and MIPS chips are famous examples valid for mobile and embedded units. Now my teammate Sanjay will say the presentation.
Hello everyone, my name is Sanjay Praveen and my register number is 486 and I'm going to be talking about CISC architectural details. So CISC instructions may vary in size and offer numerous addressing modes such as direct, indirect, indexed and more. They support complex commands such sometimes combining arithmetic, memory access and branching in one instruction. x86 CPUs from Intel and AMD are classic CISC designs. Microcode is often used to translate these instructions into multiple steps internally. Now I'm going to be talking about the execution flow comparison. So RISC, so of course RISC is CISC. RISC instruction tend to compete in a single clock cycle, fostering fast and simple pipelines. CISC, on the other hand, it can take instructions and take multiple cycles and need control logic, slowing down parallel execution but allowing tasks to be done in fewer lines of code. For example, a memory to memory addition is a single instruction in CISC but requires several in RISC. Now I'm going to be talking about the performance matrix of RISC and CISC. So the measuring CPU performance means balancing instruction count cycle per instruction, and clock rate. RISC achieves low CPI by executing simple instructions quickly, while CISC reduces total instructions by sometimes needs more cycles per instruction. The best choice depends on if you want sheer speed or to economize on memory and developer effort. Now I'm going to be talking about pipelining and parallelism. RISC's regular instruction size supports deep pipelining. Several instructions can be infight simultaneously. CISC's complex decoder and variable length instructions can hold up to the pipeline. Modern CPUs, though, often convert CISC instructions to RISC like micro-ops for faster parallel processing. Now my friend Harshad will be continuing from here.
I'll be explaining about memory and compiler differences. So, we're going to explain about memory and compiler design in RIC and CISC. So, RISC systems rely on clever compilers to turn complex programs into a series of simple register operations. This can increase core size but improves clarity and cache performance. CISC lets hardware take on more work directly, which can result in denser code and potentially less RAM use. But it requires more sophisticated cache and branch prediction strategies. Now I'll be explaining about real world examples. RAM and RISC are everywhere, like in phones, tablets, and many IoT devices. Thanks to the speed and power efficiency. Uh, a model like x86 CISC processors rule desktops and servers, where running all the softwares and handling big programs is essential. Modern chips sometimes mix features decoding CISC instructions into micro-ops running optimally in all sorts of environments. Now I will be explaining about what we can summarize and take away from this presentation. To sum up, RISC is all about simplicity, predictability, and efficiency. It is a key for mobile and battery optimized applications. CISC is all about power, flexibility, and compatibility, excelling in PC and server worlds. Most modern processors blend both ideas for optimal results. Understanding these differences helps us make better tech and smarter choices in the real world. Thanks for listening. Hope you enjoyed it. Thank you.